Hi everyone, so this is question 7 from tutorial sheet 2. So the first question is tan x minus sine x, minus sec x squared is equal to 1 plus sine x over 1 minus sine x. So for this question to be solved, you have to look at the most complicated part. And okay, you can start from either side, but I would like to start from this side myself. So I'll say let my left hand side be equal to 1 plus, sorry, this is my right hand side, be equal to 1 plus sine x over 1 minus sine x. So here the first thing that you do, find the conjugate of that. So the conjugate of that will be 1 plus sine x, the conjugate of the denominator, and then on top there you write the same conjugate. So this conjugate is just in a way that it is just the same as adding nothing to this, because this divided by that you get 1 times that, you get the same function there. So when you multiply there, you're going to have something like this. So this when you look at the denominator here, you discover that the denominator there is just the difference of two squares, which is just the same as writing 1 minus 1 squared minus 1 minus sine squared x. Then you have that. If you have that on top there, you have this, just the same as writing 1, then that and that, it's just the same as writing 1 plus sine x, and then everything squared, because this and that is just the same, meaning this times that is just the same as writing as that. So you can also write this as, we know to say 1 minus sine theta from this identity here, sine squared. So sine squared x we know to say plus cos squared x. You know to say sine squared x plus cos squared x, you get a 1. So when you take this sine, that side it will be 1 minus x, or 1 minus sine x squared, which is just the same as cos. So where there is 1 minus sine x squared, I can also replace with cos. So on top there I have 1 plus sine 1 plus sine x, and then squared like that, and then on the denominator there I said I can replace with cos squared x like that. So since this and that is squared, according to the rules of indices, I can write it as everything in brackets like that. Then I'll put the squared outside, then I'll write 1 plus sine x, 1 plus sine x, and then in the brackets there I'm also putting cos x, such that if I was to distribute the squared here, I will still go back to that. So this is just the same as 1 over cos x, and then plus sine over, so sine x over cos x. Then you put everything in brackets and then squared like that. So from there what you do is 1 over cos x is just the same as sec x So 1 over cos x is just the same as sec x, and then plus sine over cos is just the same as tan. It's just the same as tan x. Then I'll put everything in brackets like that, and then squared. So this is how your final answer is. Hence, you even write hence proved down there. But when you look at the question here, there is a minus here, which implies that it is a typing error. They were supposed to put a plus here, not a minus. So let's move on to the next question. So the next question is this. Is B, but I don't know which one I can solve. They all look to be anyway, I don't know which one I can solve next here. Okay, let me solve this. Okay, the key to proving the identities, let me just give you the key and then maybe I leave it there, because me solving just solving these questions will not help you unless you know how and where I'm getting the things and the clues for me to solve them. So the key to solving these identities, you just need to know a few identities, which are sine. The first one is sine. Sine squared x plus cos squared x. Cos squared x is equal to 1. So this is the first identity that you are supposed to know. And then the second identity that you have to know, you try to divide everything here by sine. So sine, when you divide sine by sine there, so sine by sine, you're going to get your answer to be 1. So cos by sine, you get your answer to be cotangent. So it will be cot squared x is equal to, and then this one divided by sine, you get your cosec x, and this is supposed to be squared like that. And then you also try to divide this by cos. When you divide this by cos, sine divided by cos, you get your tan there. You get your tan x there, tan squared x there, and then you divide cos squared. You divide cos squared x divided by cos, you get your 1. And then when you divide 1 by cos this side, you get your sec squared x. So this is, so from these three identities you can solve all these questions here, just from these three identities here. So where there is cot, for instance on B, where there is cot squared plus x here, you can replace with cos x squared x. Where there is tan squared plus x here, you replace with sec squared there, and then you simplify it in order to get this cot x. Same applies here, where there is same applies here. You can first try to expand this, and then after expanding, you find means and ways in which it's going to become like that. So that is how you solve identities. I don't know if there is any other question that, okay, let me solve the last one here, D. I'll solve D, and then maybe these remaining ones, what you do is you can solve it, and then you can send your solution to this line here on WhatsApp, and then I'll check if whether you are correct or not. Actually, for identities, you can even mark yourself, because you know that if you are solving, and then let's take for instance you are solving this one and then you don't reach to this answer, it means that you are wrong, you made something wrong. So unless you just like completely fail to solve the equation, that's when you at least solve something and then ask me on WhatsApp to say where am I getting it wrong, and then I'll be able to show you. So let me also solve the last question here. So the last question is saying this is equal to that. I'll solve D. This is equal to that. So this one is also simple and straightforward. How? Because I'm just going to equate this first part here. Sine x over 1 plus cos x sorry, this is x is equal to the left hand side. Left hand side. S. And then here you find the conjugate of the denominator. So the conjugate there of the denominator, let me just rewrite it here. Sine x then over 1 plus cos x. So the conjugate of this denominator here will be 1 minus, just change the sign here in between to be 1 minus cos x, that's the conjugate, and then everything on top here you write the same 1 minus cos x. And then what you should put in mind when you're solving identities, you should know where you're going. You should have direction. You should know to say, I want to get this. So sometimes you can solve everything, and then after solving, you even bypass the answer. So you should know where you're supposed to end. So the down part here is a difference of 2 squares. And then the top part there, of course, it will be sine x in brackets 1 minus cos x. Then here the difference of 2 squares on the denominator can also be written as 1 squared. Of course 1 squared you still get 1, and then minus cos times cos, there you get cos squared. So you get cos squared x. So you move on like that. So 1 minus cos squared x is just the same as getting this identity and making sine the subject. When this cos crosses the equal sign this side, you remain with sine this side, and this side it will be 1 minus cos. So where there is 1 minus cos, I can also put sine x. So I'll write this sine x on top. Where there is 1 minus cos squared, I can also put sine x squared. So this minus cos x like this, and then everything divided by, this is sine squared x. So one sine there can cancel with one sine there, and then hence I'll remain with 1 minus cos x, and then everything divided by sine x. And I've found the answer. This is the answer here. So if you write down there, hence proved. So I said this is the last question I'm solving. The rest of them you can practice them, you can try them. Just follow these identities that I've written here. So thank you very much for watching the video, and make sure that you don't forget to subscribe to the channel. And if you have any questions and contributions or any corrections, you can also send them to this line on WhatsApp, and I'll be able to see them. See you in the next tutorial video.